that even on the development team building containers, there's a lot of confusion about what containers are going to mean for us and what they're going to bring to the world. There are a bunch of scenarios that I'm going to be talking about and a bunch of workflows that I'm going to be talking about where I'm going to be saying, hey, here's something that we think is interesting. Here's when we've been designing this. Here's a scenario that we think about. But over the last year and a bit more, as we've been working on getting this ready to release, in all honesty, I would say about once a week inside the development team, there's been a discussion about some design point where the conclusion has been, you know what, we just don't know. And we need to get this build out to customers, and we need to let them play with it, and we need to hear what they're doing with it and hear what works and doesn't work for them. So this is a very new technology. It's a great time to be getting up to speed and understanding it. I will, the two extra caveats that I will give on that is I have been frustrating a huge amount of people on this because when we get to the end, if we have time for question and answers, I can already preempt you and say that half the questions you ask, the answer I'm going to give is meh. We'll find out. We're trying to figure that out as we go. The second thing that I do want to be a big ask that I would have of you is please play with this technology and give us feedback about what works, what doesn't work, and what you think is interesting and exciting and what you think is kind of boring and lame. We are definitely very early in this journey, and it's a great opportunity for us to work together to shape the direction. It's a personal frustration point of mine is that right now, and this is true even of people at Microsoft, of my esteemed colleagues, there's lots of people wanting to say, okay, you're going to use containers for A and B and not C, D, and E. And we're sitting here on the development team going like, well, you could use containers for C, D, and E. There's no reason architecturally why you couldn't. It's just that we haven't built them for that yet. So we're still very much in the early process. So I have a couple of slides here where I'm going to try and talk through some architecture, some details, some motivation. I am going to try and go through these relatively quickly, knowing that there's going to be a whole bunch of points where I'm going to see confused faces and raised eyebrows. I'm using these slides to just lay some groundwork before we get to the demo. And I want to show you what this actually looks like and what this brings to the table. So why did we start working on containers? Well, there's a lot of things that have come about in the industry to make this interesting. So while I'm bringing this up, quick question. How many people have a vague idea what containers are? That's good. How many people know what Docker is? How many people have used Docker? We're getting there. That's a larger percentage. I did a presentation in February where I asked how many people have used Docker, and there was like one hand in the room. I was like, okay. A couple of things to call out here. Containers have really kind of burst into the conscience of the IT world in the last 24 months. But the technology behind containers is actually not particularly new. It's building on a set of technologies and a set of capabilities that we've had for a while. Linux has had Linux containers for actually about a decade now. On the Windows side, we've had most of the primitives and the building blocks for Windows containers. And only now have we decided, okay, let's pull these together and actually provide this as a thing that customers can use. And there's a reason why it's becoming interesting now when it wasn't interesting 5 years ago, 10 years ago. And there's a whole bunch of data points that feed into this, but there are two that really stick out for me. The first one, to tell a bit of a story and a history, we actually, as I said, we've had the building blocks for Windows containers around for ages. And I can actually remember in 2007 going out and talking to customers about something that was conceptually very much like containers and saying, hey, would you be interested in this instead of virtual machines? And one of the big drawbacks of containers versus virtual machines is containers can only run the same operating system that they're running on. And at that stage, when I talk to customers, they're like, no, that's a showstopper. I need to run different operating systems. Please give me virtual machines. Come forward to today, and all of a sudden, this isn't a showstopper. And to be honest, when we started to see the guys on the Linux side of the world starting to talk about containers and, hey, this is great, and so on, we actually had a moment of scratching our head and going like, but wait a second. How are they dealing with the fact that with Linux containers you can only run a Linux 3.8 kernel on a Linux 3.8 kernel, and if we did Windows containers, you could only run Windows on Windows. And the light bulb moment for us was when we went, oh, wait a second. What has happened is that virtualization as a technology has become so prevalent that there is now nowhere in the world that you can't run a Linux 3.8 kernel or a Windows 10 kernel. You name, Amazon Cloud, Azure Cloud, your laptop, your data center, your MacBook, you name it, you can run a different kernel there. That problem is already solved. So because that problem is solved by virtualization, then containers can actually come in and play a really interesting role. The second big inflection, and this is where I'm going to spend the most of my time talking, is there's been kind of an evolution going on in the way that we build computer systems, in the way that we run data centers, and in the way that we build software. And if you look at this from kind of an IT historian point of view, 20 years ago, we were doing it the way it made sense for physical computers. And when virtualization came onto the scene, we started off by just going like, fine, take all the processes, all the techniques, all the methods that we use in physical computers and just apply them to virtual machines. And it's great because virtual machines are easier to manage, they have higher density, et cetera, et cetera, et cetera. But then over the ensuing years, we've been developing new techniques and new approaches that make more sense inside virtual machines. So one of the things I'm going to be talking about here is a lot of the image and disk technology that we use. If you look at virtual machines, it makes a lot of sense to be like, okay, I'm going to create a master image of my virtual machine, and I'm going to use that to build new virtual machines on top of. That's a lot harder thing to do with a physical computer. So there are all these tools and techniques that we built up with virtual machines. Then with containers, what we've actually been able to do is we've been able to go like, okay, rather than building something to mimic the physical world and then adapting it for these new workflows, let's build something which from day zero is designed for these new workflows. So what does this look like? Let's go through a couple of the details. I'm going to give you just some high-level bounding boxes for Windows containers, and then I'm going to talk through the architecture of some of the imaging and deployment technology that I was talking about, and then I'm going to show you a demo where I want to spend most of my time. So there are a couple of concepts here for the ecosystem, the container runtime. The first one, I'm going to say this 100 times. Everyone is confused about this, so I expect to get questions about this for years to come. Containers are a technology that allow you to run more instances of the OS that you have. So on Linux, you can run Linux containers to run more instances of Linux. On Windows, you can run Windows containers to run more instances of Windows. They don't allow you to run different operating systems. If you want to do that, we already have a great solution for you. It's called virtual machines. And where we see, and the approach that we see the industry taking is if you need to run containers from a different operating system, great, you run them inside of virtual machines. So we have Windows containers, we have Linux containers. We have container images. I'm not going to spend a lot of time talking about this because I have several slides dedicated. And we have an image repository. So what does the container runtime look like? So you can imagine we have our physical hardware, and it has an operating system. Windows Server Core, Windows Nano Server, etc. This has the container images in it. Just a second. I haven't used this slide. So this is where we're showing you how virtualization works. So if you look at virtualization as compared to containers, see this layer between the two? This is where we provide a virtualization layer that looks like hardware. And on top of the hardware, you install a second operating system. I'm just eager to get to my demo. Where containers are different, though, is instead of having a virtualization layer that looks like hardware, we have a virtualization layer that looks like the kernel mode of the operating system that you're running on. So where the bottom layer of a virtual machine is a PCI bus and all the associated devices and the hardware interface, the bottom layer of a container is actually the kernel interface into the operating system that you're running on. And one of the things that we've been working on and having to do is we've been having to go through and do a whole lot of work to make all the different parts of the Windows kernel understand that, like, hey, you no longer have to deal with a single instance talking to you. There are multiple instances. The next thing to talk about is, and this is a huge debate in the industry right now. I'm incredibly curious to see how this plays out, is that, of course, you can run containers inside of virtual machines. And the debate in the industry right now is which one of these is going to win out at the end of the day. What we are seeing today is we are seeing that when most people use containers, they run containers inside of virtual machines. Now, the question we have is there are two ways you can view this. And I mean, you can run containers on bare metal. And there are two ways you can view this. You can say, okay, people are running containers inside of virtual machines today because it's a convenience on the infrastructure that they have. And eventually we'll get to a world where people are running containers on physical computers primarily because the infrastructure will adapt. Possible. Another way to view this is to say, people are running containers inside of virtual machines today because it's convenient on the infrastructure they have, and in fact, that infrastructure will always be easier to run containers. Therefore, we always expect containers will run in virtual machines. Also possible. We don't know. That's a big one that we're waiting to see. What do people do? How do people use this? So let's dig into the imaging approach and the imaging technology. So when you use a container, whether it's a Windows container or a Linux container, both of these start with a container OS image. And this is a base image that contains all the binaries for the operating system that you're going to be running on. When you create a container, you actually create just an empty sandbox layer on top of this base OS image. You then run the container and you do whatever changes. So you install an application in the container. And this is all getting captured in this sandbox image. Once you've made the changes, got things set up the way that you want, you then have the ability to say, okay, I'm going to take this container and I'm going to capture that into a new image layer. Now, how many people here have used differencing disks with virtual machines, understand that concept? Okay, how many people here have looked at the size of their differencing disks and been staggered by how large they are? So, differencing disks are absurdly large for the amount of data that they store. And the reason for that is with virtual machines, because we're virtualizing at the hardware layer, we don't have an understanding of file systems. And we have to do our differencing at the block layer. And so if the guest operating system goes and writes out some temporary data to a place that we don't care about, it gets captured. If it touches a file, if it messes around with stuff, it gets captured. And so those differencing disks end up being huge. Now with containers, a core part of containers, for architectural details that I don't have an hour to discuss, is containers always have a file system level view of themselves. So these differencing layers are actually implemented at the file system level, and they are very small and lightweight. I was actually, to give you some idea, I was demonstrating to someone the other day. I just created a container, created a small file in it, and this was a full Windows Server core container, and I exported the layer, and it was about 7 meg in size. So I had 7 meg of data overhead for storing my stuff in a container. Similar one of the favorite things that I run in containers right now is Minecraft servers. I can create a Minecraft server, export an image of a Minecraft server, and it's about 200 meg in size. So pretty much just the data that you actually capture. Now, once you've created this layer, you can go ahead and create new containers using that sandbox layer. So I'm going to jump ahead because I want to demo. So what does this all look like? Wake up my mouse. Now, this is couple of words of caution and advice. We have released a public preview of Windows containers about 2 weeks ago now. At this point in time, we have said we are only supporting Server Core and Nano as container images. Please note the use of the word "at this point in time." This is one of those classic ones where it's like, can we run different different SKUs of Windows in there? Absolutely. It's just a matter of engineering time. So we're working on lots of stuff, but at this point in time, it's Server Core only. So I am going to be doing this demo using a Server Core virtual machine. I apologize if you don't like text, because there's going to be lots of text in the demos today. And because there's nothing more painful than watching someone type slowly and make typos, I do have notepads with all my demo scripts. So I'm going to be doing copy and paste, so you don't have to watch me fat finger things. So this virtual machine here, just basic Server Core installation. If I do ipconfig, you'll see, okay, I have 2 IP addresses there, and that's what we have. Now, at this stage, this is a clean system. Let's do get container, there are no containers. If I do get container image, you can see, okay, I've got a single container image, which is Windows Server Core. That's the one that comes with the system. I can also do get VM switch, because containers actually have full networking capabilities. And we're supporting, first we're supporting all the standard switch technology that you're used to with virtual machines today. But we've also added the ability to have a NAT-enabled virtual switch, which is what we default to, and what I'm going to be using for the demos today. Now, I will just say, for those of you who go and play with this technology at home, we do recommend the NAT-enabled switch for 2 reasons. The first reason is it's the more portable option, i.e. if you want to take this and run this in Azure or in AWS or in your hosted cloud, then we know the NAT virtual switch will work. Whereas if you try and run a full virtual switch inside a virtual machine on someone else's fabric, they may not enable that. The second reason, which is kind of more important, every time you start and stop a container, if you're not using NAT, you will grab an IP address from your DHCP server and throw it away very quickly. We had, amusingly enough, on the development team that's been building this technology, we have frequently exhausted our building of DHCP addresses. It is not uncommon to, we've actually got used to this. We have a support DL, And if we get people start emailing around 2 p.m. and going like, something's wrong with the build, I'm starting containers and I'm not getting an IP address, we're like, we're out. We've run out of IP addresses for the building. So anyway, so here I'm going to run this command, which I'll just show you. I'm saying, okay, create a new container, call it my container, use the container image Windows Server Core, and use the switch name virtual switch. And that will just take a second. There we are. I can do get container. I can see the container I just created. Then I'm going to run these 2 lines. And what these 2 lines are going to do is they're going to say start the container and then enter a PowerShell session inside the container. And this second line is using the technology that we built for VM for PowerShell Direct. So this actually works even if I have a container without networking. So now I have an entire new instance of Windows that quickly. If I run ipconfig, you're going to see I have a different IP address in here. It has its own file system and it has its own registry. It has its own system identity. So now that I've done that, what I'm going to do is I'm going to run these 2 commands, and they're just going to pull down the binaries for the Nginx web server, and they're going to lay them out on the file system. So there we are. I've just downloaded those files and put them in. I'm demonstrating Nginx here. IIS also works. Apache works. Node.js works. This is just the script I had handy. So I'm going to exit out of this. And if I do a get container now, you can see that, okay, my container's running. It's been running for about a minute, so let's stop it. That's too long. So if I stop the container, now what I can do is I can say, hey, I want to create a new container image from that container. So I've got the name, my version, my publisher, and that's exported it into an image. So now I can go, okay, I've got 2 images. I've got my Nginx image, and I've got my Windows Server Core image. Now what I can do is I can say, okay, let's create a new container using that image that I just created, the Nginx. So I'm going to start the new container that I just created. I'm going to enter it. Okay. So we've now got a new container, yet another system running, different system identity, but it's got the files that I put in that layer, and I can start the Nginx website. You can see that there it is running. So, okay, that's cool, but let me just kind of break this down for you. If we wanted to do this with virtual machines, and I know people who do this with virtual machines, what this process would have looked like is, okay, I'm going to create a new virtual machine, I'm going to install Windows, I'm going to get that all up and running, I'm going to install the patches, I'm going to get it configured, I'm going to Then once that's all done, I'm going to sysprep it, I'm going to shut it down, that's going to be my base image. Then I'm going to create a second virtual machine, I'm going to boot it up, I'm going to have it go through generalization, I'm going to install the web server application that I want to do for that. And once again, I'm going to sysprep it and shut it down. And now I'm going to have that out. And now I can do this process. And one, like, if you are really good, this only took you 5 hours. Like, if you are good. 2, at this stage, you have now successfully got yourself to a world where you can provision new web servers on demand in a mere 10 minutes. And 3, in order to support all of this, you've probably got about 40, 50 gig of disk space sitting around waiting. What I've just showed you is doing exactly the same thing in about 2 minutes. And I can now spin up repeatedly new web servers, new server workloads in about 10, 15 seconds. The final thing to highlight here is, let's exit this guy. So I've got 2 containers defined. So this is a nice little trick I can do because these are running in a Hyper-V virtual machine. get rid of that. So this is the virtual machine that I'm using. So currently, it's got a memory demand of 614 meg of memory. If I start 2 containers, it's going up to 819. So each of those containers are using about 100 meg of Windows, of memory for a full instance of Windows. And what's really interesting is when you start to get your head around how easy and quick it is to provision these and use these, it can really change the way you view, okay, how am I going to operationalize them? How am I going to use them? How can I use them in a development process? One of the really fun and interesting conversations that I've been having over the last 2 weeks since we provided the first public preview of Windows containers has basically gone like this. The person I'm talking to says, so Ben, I've been looking at Windows containers, and I can't figure out how I can modify the container image offline. I want to do offline injection of files and configuration and so on. And I look at them and say, well, you can't. And usually at this stage, they get very confused and scared because that's the world that they're used to. And they're like, what do you mean you can't? I say, well, you can't, but you don't want to. And they're like, then they're really confused. And then I'm like, here's the deal. If you can start a container in a second, and it uses almost no memory, and it uses almost no process, and you can always get a PowerShell session in there even if the networking's broken, and you can stop it instantly, why do you need offline editing? And this is actually a really interesting conversation to have because there's a lot of tooling and processes that we've developed as an industry to work around some of the shortcomings of virtual machines. So let's jump back to my presentation. Now, as I said, we're still trying to figure out, hey, when are you going to use containers? What are the scenarios? What are the different workflows? There are some scenarios that we have identified already as like, hey, this is really cool, and this is really powerful. One of the big ones is for people developing server applications. And these are, and this is one of the first places that we started looking at virtual machines. But if you think about the little demo that I just showed you, you can imagine now if you have developers who are working on a server platform that has different requirements, has different infrastructure requirements, you know that even with virtual machines, it's a frustration and an annoyance for them to get that environment set up. Yes, thanks to virtual machines, we've gone from setting up a development environment taking weeks down to it takes an hour or two. With containers, we can now have a world where I can go, you know what, I need a new development environment, and be up and running in a minute or two. So the workflow here is, if you think about how I created the image, I didn't show you this in the demo, but we also have the ability for you to export those images to a file, put them on a share, import them, you can move them around, etc. So imagine that I built that, and then I go, okay, great, this is my web development environment. This is what we're going to build on at this company. Let's export that, and then just tell developers, hey, you want to get going, here's the 50 meg file that you pull down, you import, and it's going to detect that, like, okay, you've got the right version of Windows Server. And the developer can then start developing on it. When they're done developing, they can actually capture their changes in their own layer and provide it back. So one of the things that's always been imagined, and we've actually done a lot of work on this, is like, man, wouldn't it be great if we could have a workflow where not only are you developing virtual machines, but if you encounter a bug or if you have an issue or if you need someone else to look at it, you can just give them your entire environment and they can have a faithful reproduction of that. And that's never really taken off because with virtual machine technology, one, there's just too much other state in that virtual machine. And two, the files are just too large. We are not in a world where it's a viable statement to say, yeah, you want developers on your team handing around 10 gig files so that they can look at bugs and reproduce issues. That's not the world we're in. So having the ability to say, okay, let's just share that image lightly is really handy. The more powerful thing, though, and this is where we kind of see the future going and we're really excited about, is that if we can have containers both as tooling for developers, but integrated into the operation side and into the infrastructure side, we see a world where, okay, your developer is going to do their development in a container, and then when it's time to go live, they can just provide you with the container image. And you can run it on your infrastructure. And the great thing about this is you now don't have to worry about dependency differences in the environment. It is the same. So I have a demo of this. This is actually, for me, this is one of my favorite demos. So we will switch over here. Let's get rid of that. Find the right command prompt. Look at all these command prompts. So for this demo, I'm actually going to be, first I'm going to do this demo, then I'm going to spend some time talking about Docker and the work that we've done with Docker and how that all plays together. I'm going to be using Docker in this demo, but this is my fictitious developer scenario. Let's bring up my little text file. So I have written a nice little console app which I can run here. Hello world and hello world from my improved writer. Because if I bring up my project here, what you're going to see is I have a console write line, and then I have a second line that I've written with my own library, which I think is even cooler than console write line. Because, console write line needs improvement. But the key thing about this is in writing my little improved console write line, what I've actually just done is I have taken a dependency on a DLL that's actually installed by Visual Studio. This is now the classic, it runs on the developer's box moment. Because if I were to take this little simple app and give it to my operations guy and say, hey, now deploy this, it's going to blow up. But if I'm using containers as part of my workflow, let's come in here. I'm going to publish my application. And then what I'm going to do is, this is the Docker command that just says, hey, take that application and build it into a container for me. And this is just taking the files that were outputted from that app and rolling it up into a new container image. Let me grab the next command. So that's all built. I can say, okay, let's test this application out. This is now spinning up a new image based on that image that I've got. It's got my latest binary in it. And oh, dear Lord, this doesn't work. And now, here locally on my laptop, I've been able to test my application in a clean environment, and I can go, oh, if I give that to the ops guy, that's not going to work. So I can go and I can fix the problem. Let's just get rid of my offending line. And very easily, I can rebuild that environment, and I can test it and confirm it. Now, this is a great local test tool, but as I said, where we actually see this going is we see that, hey, if I have this test tool, rather than giving my application to the ops guy, wouldn't I prefer to just give him the container image that I'm creating so that I know that this is going to run, because I know that all the dependencies that I need are captured in that container image. And there's a bug. Usually works the second time if I hit that bug. There we go. So that's just an example of where we see some of these developer workflows coming in. Now I would like to take some time to talk about Docker. So I asked before how many people know about Docker, how many people have tried Docker. Now, if I were to ask you guys, like, hey, so what is Docker? I'm fairly certain that the consensus response from the audience would be like, they're that container technology. They do containers. The interesting thing is that's not how Docker defines themselves. Docker actually defines themselves as a suite of tools for deploying and managing and developing applications. And containers are just a technology that they happen to use to pull this off. And this is a key detail, is Docker is a container management suite. It is the most popular container management suite on the Linux side of the world. And we actually reached out to them when we started working on Windows containers and said, hey, what can we do to work together? And we've actually had a fantastic collaboration with the guys working on Docker, so that when we launched our first public preview of Windows containers, we also launched with full support for Docker. Now, one of the common conversations I've had around this is people saying, like, oh, so you're supporting the Docker APIs. It's like, no, we're running Docker. What we've actually done is we have been publicly contributing to the Docker project. Actually, Microsoft employee, we have one Microsoft employee who's now the fourth top contributor to Docker. When you run Docker and use Docker to manage Windows containers, we have a script that just goes and pulls down the latest binary from their GitHub account and sets it up for you. It's not a compatibility layer. It is genuinely running Docker. So for this demo, let me bring up all the command prompts. Which, by the way, if you've never used that feature of Windows, the feature to lay out Windows is fantastic. I have to bring this up. So that's just Windows key arrow. So Windows key arrow right, Windows key arrow down, and it snaps it into a quadrant grid. So what I actually have here is, behind the scenes, I have two virtual machines. One is running Windows Server Core, the Technical Preview 3 build with the container bits enabled. The other is running Ubuntu with Docker enabled. And then in my host computer, I have the Docker client installed. And you can see I've got these little commands saying demo Windows Docker, demo Linux Docker. All that command does is it sets the environment variable to say, hey, which remote server are you going and talking to? And it's a handy reminder to me. So I can quickly do some commands. Docker PS just confirms that we have no container images defined. So here's the first fun one, is I can come over to here and say Docker images, and this actually comes back and it says, the wrapping's a bit funky because of my resizing, but it says like, oh, I've got my console app running from the demo I just did. I've got my ASP5 image. And this is the console app that I showed you was actually an ASP5 app, and I've got some stuff set up where I'm doing ASP5 website publishing. So that's an image layer that I created with ASP5. And then I have my Windows Server Core base image. If I come over to my Linux side, I can run it, and there's my Ubuntu base image. So the really fun thing, and let me just, for people who haven't used Docker, let me just explain some of this syntax. This command says docker run, create a new container. The --rm says, when the container is done, please delete it automatically for me. Something that I use in all my demos, otherwise I end up with 1 million containers by the time I'm done. The -it says, oh, give me an interactive console. By default, when you start a container using Docker, it spawns it as a background process because it's assuming that you're running some web server or something that you want to run as a background process. Because I'm doing demos, that would take my already boring text-only demo and make it even more boring. So I want the interactive console. Then I say, OK, here's the image I want you to use. And the final thing I provide is, what's the command I want you to run? So I'm going to spin up 3 of these. Here, I'm going to start command prompt. Here, I'm going to start PowerShell in a container. And finally, I'm going to start my Linux container. And we can have a look here. I can do ipconfig. That guy's got that IP address. That guy's got that IP address. And this guy's got a different subnet range, but here's his IP address. Now, I've just, in that time, created 3 new operating system instances in containers. These actually all have their own separate namespaces. They're all networked. So I can ping my host. Let me just copy that. So they're all got network connectivity. They can all reach out to the host. They also all have their own process spaces. This is fun. If I do task list on this guy, you can see, OK, we've got a core set of system services running, and I've got my command prompt. If I come over here and do get process, you're going to see that this guy doesn't have command prompt, but he has PowerShell instead. So I've very quickly, rapidly created these environments and got them up and running. So let's jump back to the presentation. So what are some of the things that containers offer? So I've been demonstrating a bunch of these. So they're really fast and lightweight. And I cannot underemphasize how important that is to the sort of scenarios that we're expecting to see people take up. It's actually been really interesting as we've been working on these in the core engineering team at Microsoft, the number of things that we've actually been looking at inside of Windows and going like, hey, do you know what would be great? It'd be great if we stuck that in a container. Because all of a sudden the idea that like, hey, we have this framework where we can take processes, take subparts of programs, stick them into isolated containers, and get extra benefits from that is great. They have a great state separation model. It's very clear what's in the container and what's outside of the container. They will have resource controls. Our current public preview does not have much in the way of resource controls. They are immutable in that I can spin up, every time I run a new container, I get exactly the same thing. I know exactly what I'm getting. And of course, they have the rapid deployment model. So there are a bunch of things that we know that they're ideal for. One of the things that I like to point out when I'm talking to people is as soon as I hear the phrase scale out web proxy, or scale out whatever proxy, I'm going like, hey, have you thought about containers? Any workload that you scale up and scale down rapidly is going to be better with containers. They're also really great for if you have workloads that are batch-oriented. We get stuff in, we have to do processing on them, and then we don't need that system around anymore. Containers are a great fit. But once again, we're still trying to figure out, hey, what are people actually going to use this for? So my big ask, play with it, let us know. The next thing to talk about is we have announced, what I've been demoing today is actually Windows Server Core containers. That's the only thing that we've made available with our first public preview. We have announced that we're going to be doing Server Core and Nano Server containers. And let me say, if you've been impressed with the start times and the memory usage and so on of server core containers that I've been showing you today, we expect that all to be substantially better when we release nano server containers. The final thing, I'm actually going to skip over a bit. Actually, no, that's the slide I want. I thought this was a different slide. The final thing I want to talk about in this session is a technology that we've announced that we're working on. I actually believe that my PR people have announced that we will have a preview of this technology available by the end of this year. So I'm going to go out on a limb and say that. But we've announced that what we've released in this current build is Windows Server containers, but we're also working on Hyper-V containers. So the key concept of Hyper-V containers, and the big detail difference here is when you use Windows Server containers, you get all the goodness that I've been showing you, but you do take a hit in isolation compared to virtual machines. You do not have the hypervisor level of isolation, you have the kernel mode level of isolation. And I get people asking, well, what does that actually mean? And the short answer is, without spending 8 hours to go over Windows kernel architecture, it's a bit hard to give an answer. But there's a great example that one of the guys on my team thought of. Let's imagine that you have a set of applications that are running inside of Windows Server containers on a single system. One of those applications calls into Windows and says, hey, I want to change the power policy. I want to set the power policy on this system to the power saver policy. Well, the power policy is a kernel mode function that is exposed to user mode applications. So the kernel would accept that and say, okay, fine. Now, then an application in a different container comes along and says, you know what, high performance, like turn everything up. Well, what's the kernel going to do? Well, of course, it's just going to be like, okay, someone asked for something different, I'm going to do it. And there are places and situations like that where it's like, hey, if you're using Windows Server containers, you may hit issues if applications are calling into services and not aware that there are other services on there. With Hyper-V containers, what we're doing is we're taking all the infrastructure, all the tooling of Windows Server containers and providing an extra layer of hypervisor isolation on it. Now, there's two things to understand here. The first thing is the big message that we're going out with is we're saying, look, Windows Server containers are great for many environments, but when it comes time to go live production in a multi-tenant environment, we believe that Hyper-V containers are going to be the right story to go with. But the second thing, and this is a big goal from the development team, is it has been our number one goal with these two technologies that we want there to be zero tooling or user experience difference between Windows Server containers and Hyper-V containers. We literally want this to just be a runtime option. So you can work with Windows Server containers, get everything working, and then you can have your developer running on his laptop going like, yeah, I'm using Windows Server containers. He can export a package, give it to the ops guy, and the ops guy can go, I'm going to deploy this as a Hyper-V container. And that's going to work just fine. So how are we going on time? I've got 10 minutes. I'm going to jump over. I've got a bunch of build slides that talk about how this all comes together. I'm actually just looking at my slide thing. I'm going to pause on this slide because I have about 5 slides after this that just recap what I've said. So at this stage, we've got 10 minutes left. I would love to open to questions. I will be shocked if people don't have questions about all the stuff I've just. So the question is, how do you deal with persistent data or databases? This is, as I said, this is a big point of discussion and controversy inside the team. So the first thing to be aware of is, while containers lend themselves to stateless applications, they don't have to be stateless. We do actually persist the state in a container, but we do not recommend that people use that. For an application like a web server or like a database, what our recommendation is that you want the container to contain the runtime, and you then want the data for the service to be stored externally to the container. Now, when it comes to, okay, you say data stored externally to the container, what does that look like? We are actively in the middle of building that bit. And we are actively debating that. So we have the first public preview that we've come out does not have any built-in persistent data store. So for people who are playing with the preview, the answer is, well, you're going to want to file share somewhere, and you're going to use SMB, and you just store persistent data outside of the container. We have a number of options that we're looking at. We do, one thing that I can guarantee is that by the time we RTM Windows containers, we do want to have built-in functionality to say, okay, here's the persistent data store. Where most of the debate is right now is, should that be a file system semantic? Should that be a disk semantic? Should that be a blob semantic? What's the right thing for what customers are looking for? So hopefully that answers. Patching. Also, something we're madly debating. And as I said, I'm going to give this answer to many questions. There are two schools of thought here, and right now we're not entirely sure which is the right one. And we are pursuing both and trying to figure out which one's both technically viable and which one's most interesting to customers. Now, if I went full on drinking the Kool-Aid for, new world of Windows containers, I would say the way that you patch containers is that if there's a patch, you update the image and you rebuild any affected images on top of that. And that is the answer that is used in most container management systems today. If I go old school Windows approach, I go, well, you apply patches live and, we have the whole servicing infrastructure and so on. Now, there are pros and cons to either side. If we go down a path where we say, okay, we're going to let you service and patch the endpoints of a container image tree, then you now have the patching hell that we are all familiar with today. On the flip side, if you go with the model where you say, okay, if there's a patch, you update the base image and you rebuild your image tree, one, we do have a concern about how painful is that going to be. And two, and this is actually this is a bigger issue around containers in general, is right now most Linux tooling, Docker included, goes with the rebuild the world to apply patches model. And what we're actually seeing is people just aren't patching, which is actually quite concerning. There was actually a newspaper piece done about 2 months ago now where a security firm just went over and did an audit of all the images that were in the Docker repository and found that 70% of them hadn't been patched against Heartbleed, as an example. So that's something that we're actively working on. With the public preview that we've released, we've said, man, this is an alpha build and we're not servicing it. So go play with it and understand that at some time in the future we'll give you a new build where we'll ask you to blow everything away and play with it again. But getting the patching and servicing story right is very high on our minds.
How do you cope with something like the and impersonation?
So everyone's asking the questions I don't have the answers to. So the question was, how would you deal with a web server doing Active Directory authentication and impersonation? The answer is, the current build we have doesn't have Active Directory integration for the guest workloads, and we're actively working with the Active Directory team to come up with the right answer here. So one of the big challenges that we have around this is that there are a lot of workflows. So first things first, we fully understand we need to figure out how to have workloads integrated into an Active Directory environment for this to be viable. However, we also have the challenge that when we have containers that you can spin up in a second, run for 10 seconds, and then throw away, Active Directory as it is designed today does not work in that environment. On the Linux side of the world, they've gone down the path of using certificates for identity. We don't think that's a great user experience. I've yet to find anyone who loves setting up and managing PKI servers and certificates. So we're actively looking at that. Once again, with the technical preview that we've provided, we don't allow you to do domain join. We do require you to use certificate or other forms of authentication something that we're looking at.
Is there any plan longer term to bring this to like regular Windows Server or, for example, Windows 10?
So the question is there any plan longer term to bring this to regular Windows Server or Windows 10? Let me answer this on 3 levels. And the answer is yes, no, and maybe. In that order. So the yes answer is be aware that I work on the core development team that works on the guts of Windows. And yes, we've put this together so that in theory it works for any combination of Windows, and we certainly could do that. So nothing, like there is nothing architecturally that says you can't use containers for for all the versions of Windows. And we are actively looking at, as I mentioned, we are looking at like, hey, where can we use containers in different parts of Windows in order to solve different customer problems? So that's the yes answer. The no answer is we have been very clear that for the next 10 months, we are working on Windows Server Core and Windows Nano containers. And we are going to be very, very busy getting those technologies out in the Windows Server 2016 release. So I would not expect to see anything on that. Like, don't expect that I'll be out here at next year Ignite going like, and here's a Windows desktop container. And the maybe answer is one of the big focuses that we had while we were building Windows containers was we wanted people to be able to run these anywhere in a virtual machine. And so one of the things that, and I do this all the time, is, run Windows 10 on your computer and have a virtual machine running Windows Server Core, running containers. And we're actually doing a lot of work there to give you a great tooling experience, so it actually feels like you have containers just natively available. So the question was, what are the licensing implications? And the answer is we haven't figured that out yet. Thankfully, there is a poor, unfortunate person on my team who I do not pay enough, who has been on point for meeting with all the licensing and business people to figure out how we're going to license that. It is something that's being actively discussed.
This also applies to Hyper-V, but are there plans to support wireless adapters other than physical adapters for this sort of for the networking switches?
So the question is, are there plans to support wireless adapters rather than just physical adapters? So there's a two-part answer to that, three-part answer, multi-part answer to that. So to go down the list, one, we actually support these today too badly. Now, the reason why we support it badly is that virtual switch and wireless are anathema to each other. The way to view a virtual switch, and I love to call it this when I have security guys around, our virtual switch is a highly performant, well-tuned packet spoofer. That is what it does at the end of the day. We have, in our virtual switch technology, we have built something that can not only forge network packets to look like they came from someone else, but can do so at in excess of 10 gigabit. But the wireless spec actually doesn't allow you to forge packets. It is forbidden by the wireless infrastructure. And what we do and what everyone does is this terrible thing where we half forge a network packet. That's an awful thing. And you actually end up with this network packet that technically meets the spec, but what we actually see is when we do that, there's a bunch of network infrastructure that loses its mind when it sees those packets. So actually, it's kind of interesting. The most common cause that we see where someone's trying to use virtual switch with wireless networking and it's not working, the actual fault is in the DHCP server on the network they're connected to. Because DHCP servers should be able to accept the network packets we produce, but a lot of them don't. Because we actually, in the case of wireless, will actually produce a network packet where the transmitter the transmission identifier MAC address is different to the DHCP client MAC address. And if you've written your DHCP server right, then you should go, that's a client and I'm sending it to someone else, and that should be fine. But there are a lot of DHCP servers that don't. So, and the most common thing that we see when someone has a DHCP server that doesn't handle that is if you see your virtual machine getting the same IP address as your physical computer from your DHCP server. Which I will say, a little side note, easiest, and I put this in air quotes because this is how I solved it and I don't understand why other people don't do this, easiest way to solve this is just turn off your DHCP server and your wireless router and stand up your own one. The Windows Server 2012 R2 DHCP server handles those packets just fine. So all that said, one of the things that we have been working on for Windows containers, and we are working to roll it out into virtual machines as well, is the ability to have a virtual switch that uses NAT. And that will work perfectly on wireless network adapters. So where we're expecting to be, hopefully, in the not-too-distant future, is that we will just be saying, like, hey, if you've got a wireless network adapter, use NAT. It'll work. Life's beautiful. If you do need the full virtual switch story, you can try that. Be aware that there are some issues. We are 2 minutes over, so I'm going to wrap up. Thank you all for your time. I'm going to be hanging around, so please feel free to come and ask me questions, and enjoy your last day.